lesson 12.6, which is about vertex form. So let's take a look at what vertex form looks like. F of x is equal to a x minus h quantity squared plus k. And so what we want to remember is my value for a tells me the same thing that my value for a tells me in factored form and also in standard form. It's going to tell me whether my parabola opens up or down. And then my vertex is hidden amongst this formula, and it is right here with h comma k. So what I want to remember is as I find the vertex, I want to take the opposite of h, and then keep k true to its sign. So in number 2, if I'm looking for the vertex for this problem, I'm going to take the opposite of negative 3, comma, positive 8. In number 4, my vertex is the opposite of negative 1, positive 1, comma, negative 8. All right, moving to question number 6, I need to use my graphing calculator.
Attention please, Will, Victoria, Macris, please come to the front.
So in my graphing calculator, I'm going to put in the function y equals x squared minus 6x minus 27. It's asking me to find the vertex so that I can place this in vertex form. So let's take a look at what this graph looks like, and let's get that in the window. To find my vertex, I'm going to calculate my minimum. So we see it says 2.999 between. We know that that's 3, comma, negative 36. And that's a vertex. So in vertex form, f of x is equal to x minus 3 squared minus 36. So I take the opposite of positive 3, negative 3, and this stays true to the sign. Place number 8 into the graphing calculator to find its vertex. So here's the vertex of the function for number 8 is at 1, negative 8. And what I have to remember is I have a leading coefficient. So when I go to place this into vertex form, I need to begin with my a value as being 2. And then try to take the opposite of positive 1. And then minus 8. Don't square that. All right, so number 10, we need to, again, graph this in our graphing calculator so that we can find the x-intercepts. Once we know the x-intercepts, we can write that in factored form. negative 4 comma 0. My second 0 is at 2 comma 0. So in factored form, it gives me f of x is equal to x. Opposite of negative 4 is plus 4. And the opposite of negative, the opposite of 2 is negative. Number 12, asking me to identify the form of this quadratic function. This quadratic function is in vertex form. And therefore, I can easily identify certain key characteristics like the vertex. Opposite of negative 3, comma 12. It also tells me that my parabola opens up because my value for A is positive 5. Okay. Also in number 12, I can easily identify the axis of symmetry. Since the axis of symmetry has to go through my vertex, my axis of symmetry would be x equals positive 3. Number 14 is in standard form. And what I notice in this particular problem is missing my value of c. So I'm going to go ahead and put that in because it may help me to identify some key characteristics. For example, this value right here tells me the y-intercept. And since there was no value at the end of this function, then I'm going to say my y-intercept is at 0, comma 0. And again, my a value here tells me that this parabola opens down. Number 16 is also in vertex form. So I can easily identify the vertex at negative 2, negative 7. The axis of symmetry, x equals negative 2. And because my a value is a negative, this is also going to open down. Number 18 is asking me to write an equation for each quadratic function given the set of characteristics. And I notice in number 18 they tell me the vertex. So having seen the vertex, I'm going to choose to write this in vertex form. So I'll write this as f of x is equal to parentheses x plus 1 quantity squared plus 4. And since I want my parabola to open down, I'm going to put a negative any value for a, negative 1, negative 4, any value of any negative value of a will have this parabola open down. Number 20, again, since they give that to me in vertex, or they give the vertex to me, I'm going to write that in vertex form. So let's try number 19. This one, it gives me my x-intercept. So knowing my x-intercepts, I'm going to choose to write this in factored form. So I'm going to write this as f of x is equal to, my first x-intercept is negative 3, so x plus 3. My second x-intercept is positive 4, so x minus 4. And if I want my parabola to open down, I need a negative value for a, so let's say negative 2. So to start number 21, I'm going to get a graph of this function, this vertical motion function, and we can kind of see what that graph looks like. And then we can go ahead and answer questions questions about key characteristics? So f of x is equal to, let's try that again, negative 4.9 parentheses x minus 3 close parentheses squared plus 60. Okay, let's see what this looks like in the screen. So we need to adjust our window. So we got an idea, look at what this problem looks like. But looking at my equation, I can tell some key characteristics, some important features about this problem. For example, I can tell that my vertex is at positive 3, positive 60. I can tell that my parabola is going to open down. And I have an axis of symmetry at x is equal to positive 3. In terms of the problem situation, what this vertex means is at 3 seconds, the softball is 60 feet in height. Which describes my maximum height, say maximum vertex. To find the x-intercepts, I'm going to go back to my graphing calculator, and then we can write that in factored form. So let's take a look at my first 0. And I'm going to write that as negative 0.5 on the 0. I'm going to look at that again. And I'm going to check this on Desmos in just a minute. Let's go ahead and look at the second y-intercept for the second 0. Sorry for all the noise. And it looks to me it's going to be at 6.5, 0. All right, we're going to finish up with problem 25, and I'm going to go ahead and graph this so we can get some of our key characteristics. I actually already know my domain is going to be all real numbers. And I think I know what the range is. It looks like my maximum, my lowest point is 1, comma, negative 9. It appears that it's 1, comma, negative 9. But let's just make sure. So we have y equals x squared minus 2x minus 8 doesn't look right. Let me just go back again to my graph. X squared minus 2x minus 8. All right, I went back and I changed my window, and this looks a little bit better. Not sure what happened the first time, so let's try that again. Let's find the minimum value. Okay, I like that better. So 0.999, very close to 1 comma negative 9. So that means that my range is y is greater than or equal to negative 9. All values greater than negative 9. My x-intercepts are at positive 4, 0, negative 2, 0. My y-intercept down here at 0, negative 8. And so finally, I want to find my interval of increase. Again, we want to remind ourselves that's over the domain. So from negative infinity to 1, and from 1 to positive infinity is my interval of increase. So we'll start with the interval of decrease. That's from negative infinity to 1. And then my interval of increase is from negative 1 to positive infinity. So when we look at that, let's highlight a few things. So my interval of increase is this portion of the graph right here, and my interval of decrease is this portion of the graph right here. And then it's looking for the function in factored form, so I'm going to take a look here at my x-intercepts to help me with that. And my function is f of x. And my first x-intercept is 4, 0, so x minus 4. My second x-intercept is negative 2, so x plus 2. And I didn't notice, but we also have to write it in vertex form. So to help me with that, I'm going to take a look here at my vertex. So circle my vertex here. So in vertex form, that would be f of x is equal to x minus 1 quantity squared, the opposite of 1, negative 1, and minus